Hello, everyone, and welcome to this session. The idea of this session is to help you all understand on what are the various applications of data science and data analytics, and what is the core difference between certain rules and certain terminologies, such as what is the difference between artificial intelligence, data science, data mining, machine learning, deep learning. There are a lot of terms which people are using. And what is the difference between the roles such as data analytics, data science, data engineering, etc.? That is exactly what we will, discuss, and we'll discuss about applications so that you all get some idea on how data science or data analytics or artificial intelligence, which is the most emerging trend currently, can be applied to your respective streams so that students need not even think about learning Java, C++. All those are outdated. Let me put it that way. Yeah. It is not at all inclined to their core that they are studying. And I also request everyone to please be on mute so that there is no background noise. That's a humble request. Okay, let's get started. So, my dear friends, lecturers, professors, I'll explain about the entire data pipeline first. What do we mean by data pipeline? There's a lot of data which is getting generated in the current world that we live in. And all the animations that I'm going to show, these kind of animations, are built by our team so that when students learn these concepts, they find it very easy to understand the concepts. I'll also share a few other additional insights here. So we have social media, which is generating data, Facebook, LinkedIn, Twitter, so on and so forth. We have IoT sensors, industrial IoT sensors also, which are generating data. You have data generated from a lot of web sources. We have data getting generated from a lot of flat files. Flat files could be your text files, CSV files, Excel files also, PDF files, etc. When you take all these data sources and put it in a database means the place where you put your data. You're basing your data in one location, hence it's called as database. The data is based in this. This process of pulling the data from different data sources and putting them into a database is called as data ingestion. So data ingestion is a process of taking the data from different sources and putting them into database. Then you take that data and that's called as raw data. Right? And then you perform certain pre-processing techniques. There are multiple pre-processing techniques. One small example that I can give you is if you have temperature from temperature sensor, say every minute you're capturing the data. Say 6th minute and 7th minute, there was some glitch because of which data wasn't captured. So these two values would be missing. Then 8, 9, 10. For doing analysis, you need data of these two also. But your sensor, for some reason, did not capture. What would you do then? Right? So you do something called as imputation. Imputation is a technique which is used to replace these missing values with some logical value. That's called as imputation. So that's one of the data pre-processing techniques. And then you apply, and then you get the data, which is now ready for model building, machine learning model building, right? So you get into model building, you build your prediction model. For example, if you want to predict whether a machine is going to fail or not, then you need historical data, the past data, say for the past 6 months, Jan, Feb, March. For the last 6 months, assume you have the data. And did your machine fail or did not fail? Say you have data in that way. fail or not fail. And then say you have a lot of inputs, temperature sensor, pressure sensor, vibration sensor, flow sensor, sound sensor, so on and so forth. So any machine learning algorithm does only one thing, and that is establishing the patterns between your inputs and your output. When temperature was, say, 80 degrees Celsius, pressure was some number, and all these sensors, when these were certain numbers, then the machine failed. So this pattern is learned. In future, when you have a similar kind of values, inputs, then your machine learning algorithm will predict that your machine might fail. So machine learning algorithm is all about learning the patterns. Using some math concepts, it's going to learn the patterns between your output variable and input variables. And then you evaluate your model. You determine whether a model is good or bad. Is it 90% accurate? Is it 95% accurate? Is it 80% accurate? You get those details. And then all the Python, by default, people are using Python, which is a de facto statistical programming language tool at this point of time. So when you write Python code, you push it into something called as GitHub. You let your code remain there. And then you deploy your model in something called a Streamlit. Because your end users might be scared to look at the programming, to look at the code, etc. If you can give them a beautiful web interface, wherein all they need to do is they just need to give inputs of all these sensors, temperature sensor, pressure sensor, sound sensor, so on and so forth. And when they click on this button called submit, they get the result on the screen that, okay, there is 87% probability or chance that your machine might fail. So such results will get displayed on the screen. It will be very good for end users. And whatever predictions you do, you store those results back into the database. This might be wrong prediction also. So you should be in a position to store the results back into the database for monitoring and maintenance purpose. This entire thing end to end is called as data pipeline. Whatever we have understood now, end to end is called as data pipeline. And this portion, wherein you get the data, you pre-process the data, build the models, and store them and evaluate them. This process alone is called as model pipeline. And the entire stuff that we discussed about is called as data pipeline. All right, let's further move on. A lot of people ask me this question, hey, what is the difference between artificial intelligence, data science, data mining, machine learning, deep learning? Hey, what is the difference between all of these? Artificial intelligence is all about automating the human intelligence. What do you mean by that? Okay, let me give you an example. Obviously, we all are aware of cars, and then people drive cars. When you drive a car, you control the steering, you apply brakes, you change the gears, so on and so forth. All these things is done using human intelligence. The moment you see a red signal, you apply brake, you change the gears, right? If you want to move towards left, you change the steering, you rotate the steering. So you are manually doing all these things using human intelligence. If I can automate this human intelligence, then it would be called as artificial intelligence. And your self-driving cars, autonomous vehicles, or UAVs unmanned aerial vehicles. All these are examples of artificial intelligence applications. I've just given you one small example. And to build such AI application, you need knowledge of data science. Okay. So you're a scientist basically who is working on data, and you try to analyze data further. Within data science, we have another concept called as data mining. Like coal mining, when you dig coal, you get coal, right? And then if you're lucky, you get some rare mineral like diamond, etc. In that way, data mining is all about digging into data. And if you're lucky, you'll get insights which are as precious as diamond. And that is exactly what all these concepts that we learn would help us arrive at. They'll help us arrive at business insights, which will be as valuable as diamond. And data mining has many things such as supervised learning, unsupervised learning, semi-supervised learning, self-supervised learning, reinforcement learning, bunch of varieties. Within that, you have something called as machine learning. Machine learning is a field within data mining. Usually people correlate machine learning with predictive modeling, building prediction models, but it's all about learning the patterns in your data. And within machine learning, there is a specialization called as deep learning. Deep learning nowadays is synonymous to neural networks. Whenever you want to analyze images, videos, while I was seated in Principal Ma'am's room yesterday, I was looking at the CCTV, the screen, big screen with all the CCTV footages. Why can't we apply AI there? Absolutely, we can. We can look at automatic attendance tracking of the students. Plethora of opportunities exist, is what I felt personally. Okay. So dealing with audio files, images, textual data, etc., is nowadays being done by neural network algorithms. No matter what you learn, no matter what techniques you apply, at the end of the day, we do only one thing, which is we build AI applications. Having said that, we have three key roles. Of course, we have many other roles like machine learning engineer, ML ops engineer, etc. But there are three key roles. Let's discuss about these three key roles also, and then we'll plunge into the use cases, the projects that we have done. So one is data analyst, another is data scientist, third is data engineer. All three would need data. Okay, all three would, sorry. Let me just wait for that screen to come up and then I'll pause it. So all three roles need data, and data would be in database. Data is based in database. And within database, you'll have something called as tables. In those tables, you'll have data. Okay, if it is structured data. As a data analyst, you take this data and you try to understand what happened from past until now. Past until now, you try to understand if it is sales data. Was the sales continuously increasing, or was the sales increasing and decreasing, or was the sales decreasing throughout for every product of yours, so on and so forth. So you create reports and dashboards and try to understand what happened in the past until present, until now. So this part is called as data analytics, and people who work in this profession called data analytics would be called as data analysts. And if you were to predict the future, what will be the sales for the next 3 months, for the next 6 months, for the next 9 months, for the next 1 year, if you start predicting the future, then you'd be called as a data scientist. And that profession that you work is called as data science. Of course, as a data scientist, you are also expected to perform the activities of data analyst. Because first you need to understand what happened until now before you predict what might happen in future. And ensuring that data from different data sources such as websites, IoT sensors, social media, your flat files of organizations that you're working with, ensuring that all the data is continuously made available to data analysts and data scientists for further analysis is the job of data engineer. So the key objective would be data ingestion when it comes to this profession of data engineering. So this is the difference, friend. And we have 4 stages of analytics. I just wish to skip that. One more very important thing is there has to be a structured project management methodology. 99% of the students who are undergoing probably BTech in data science or MTech in data science or whatever field would like to go and join different companies. They want to work with these big companies as data scientists. They might not want to get into the research field. So they would be working on projects in that case. If they're going to work on projects, you need to have a structured methodology, which is called as CRISP MLQ methodology. Understand the business problem first. Define the success criteria. When will you say that your project is a success? Then go and understand the data. Prepare your data for model building phase. Then build your model by paying attention to a lot of aspects, such as if you're deploying your model on an IoT device. Say in the CCTV itself, you want to put your machine learning model. Then your machine learning model should be very small in size. Model compression techniques would come into picture. So in that way, many things are there. Then you evaluate whether the model that you've built is apt for your business or not. Then you deploy your model, and then when end users start using your model, you continuously monitor and maintain your model. Okay. And we have also done a project for Volvo trucks, which I wish to briefly talk about here. So what happens is this is called as a clamping station. So the employee here would go and do the clamping. They close the clampings. Okay. So they are closing. They are closing. Right? When they close it correctly, then there'll be a green light which will glow. All these are the clamps. This is one clamp, this is another clamp, that's another clamp, that's another clamp. However, if the clamping sequence is incorrectly performed, then there'll be a red alarm. Such a simple, manufacturing use case this is. I'm sure in a lot of wind turbines, in hetero also, when you manufacture, drugs, there is a specific sequence which has to be followed. Obviously, there'll be a lot of process, etc., but majorly humans do the quality inspection, quality audits, quality assurance team are humans. Can we not automate? Absolutely, we can do that. Can one of the professors, basically from probably computer science or AI department or mechanical department, not take up one of these projects and then have the team which is already trained handle this? Absolutely. Right? And it'll be a wonderful thing to be done. Okay. We have done yet another project for a specific manufacturing client where there were centrifugal pumps, which was giving vibration sensor, pressure, temperature, level sensors, etc. Input for these pumps was oil, petrol, diesel. Yeah. Output also was oil at a specific pressure. That pressure is measured in liters per minute. How many liters per minute? What is the speed? Based on that, whether your vehicle is going to travel at 100 kilometers per hour or 10 kilometers per hour would be determined. Yeah. And then from that, we took the data and then we have placed the data in SCADA systems, ERP, if they have any, etc. From there, we have used gateways, IoT gateways, etc. And then we transported the data onto our database. Then we started doing the analytics on whether that machine will fail. Is there any leakage in the pumps? There might be oil leakage. There might be overheat issues. When should your vehicle next go for service? All these things are analyzed. We've also done a project for poultry. How many poultry farms would we have in Satupalli? Quite a few. Why can't we do this, right? And the kind of project that we have done here is pertaining to egg count. Let me see if I can, at this point of time, show you that particular project that I've posted here. By the way, this is my profile, friends. LinkedIn allows only 30,000 connections or followers. I crossed that. I already, I think, have 30,000. That's the max that you can have. So 3,500 people are waiting. I cannot do much other than they follow me. So not that I don't want to accept the connections. I absolutely would love to accept the connections, but I am handicapped on that front. But if you feel you want to connect with me, by the way, I'm hoping and assuming that you all have LinkedIn profiles. That's mandatory in the current world that we are living in. And not just having a profile, be active on that, please. And let me show you this thing. Is this a project? Yeah. This is a project pertaining to egg detection. This is how the eggs are counted. The moment they keep moving. Manually, you cannot count. If you have big hatcheries, you need not manually count it, friend. Eggs might be cluttered like this, right? Eggs might move at a rapid speed also, right? Even when eggs move at a rapid speed, the exact egg count is determined using what artificial intelligence. Now, humans need not sit there and count the eggs. That's called as brain drain. Brain drain means underutilization of human potential. That's one thing. Second thing is color detection, white eggs versus brown eggs. Third thing is crack detection, whether the egg is good or cracked. Third is stain detection. Are there any stains on the egg, blood stain or whatever? And we also have done a project with respect to bird, right? I can show that also. Today I'll be posting on LinkedIn profile the bird project that we have successfully completed. It will determine a lot of things such as whether that is a chick or not, how old that is, whether the beak and eye are healthy or not. And in this way, just using images, it will determine the weights of these chicks. The moment you calculate this, automatically you can give an estimate to the poultry owner that these many cages of meat is available, multiplied by money. That is the kind of money that you'll make. All these are real world projects that they have already accomplished. These are not fictitious things which might happen, right? These are all done already. And wind turbines project that I was talking about, yep, this is what I was talking about. We have accelerometer, we have position, we have transformer, we have fluid property, we have bunch of things, position, right? And using all these things, wind turbines usually are spread across a few kilometers of farmland, and using LoRa, low range, right? Up to 30, 35, or even 100 kilometers range, they do it, but it's not advisable to run LoRa gateway there. You get the data and then you put it on cloud. We have used AWS cloud instance over there, and then all the AWS services were used. And ultimately, we have given live dashboards to the customers, which will predict real time on what will be the electricity production, which machine, which component might fail. We have gone to the extent of pollen grain weight measurement. See, each wind turbine will be like 6 stories in height, 6 floors of your building. That will be the height of each wind turbine, typically, right? And when they are usually, placed in green locations wherever cultivation happens. In the adjacent areas, when they harvest, a lot of pollen grains will go and get deposited on the wind turbines. And eventually it becomes so heavy that the performance of this wind turbine reduces. So measuring the weight of the dust particles on the wind turbine is also another sensor. That data also we capture. Okay. So in this way, there are a bunch of different projects that we have worked upon. A few other quick things that I want to talk about here is the project which we have worked upon long back in 2017, right? This won the first across India. This won the first place. We competed with the likes of Deloitte, Infosys. They came up with their bunch of projects that they have done. We have also done this project. What is the project management methodology, right, etc. And when we have done it, we won the first place. So what did we do? You have trucks which transport goods from one location to another. And when trucks fail midway, without any plan, if they fail, what would happen? If your vehicle is under warranty, you'll call the nearest service center. You'll say, hey, my vehicle stopped midway. Please, can you come and fix it? They will come, they'll inspect your vehicle. If they can fix, well and good. If not, they will take it to the nearest service center and then they'll fix it. This is all time equal to money. So it's a warranty cost. Second thing is, if your vehicle is under insurance, you'll claim insurance cost to the insurance companies. So what we have done is we have placed IoT sensors on the truck, which is called as TCU units or electronics controlling unit. Electrical folks, they might feel, all these use cases are very interesting because now they feel that they became relevant in the changing world. They are still relevant because the domain knowledge is a gold mine that they are living on today. If they can leverage it properly, they will be getting more salary than any other computer science student. So this ECU or TCU, which is connected to OBD, onboard diagnostics, will then started generating data of critical components. We stored the data on the cloud, and then we predicted after how many days your vehicle will break. Your vehicle might fail. There is 80% probability that your vehicle will fail. But when will it fail? After 3 days, 4 days, 800 kilometers, 600 kilometers, when will it fail? We also started predicting that. Not just that, we also started predicting the exact component which might have failed. And this solution was implemented in 5,000 trucks in this particular company. Okay, this company told do not disclose our name, so I will not disclose, but every second truck that you see in India is manufactured by this company. You can guess the name of the customer, but I would leave it there. The next thing is, a few of our friends while I was interacting yesterday was saying that, you know what, we trained our students on Tableau as well. Again, training is no big deal. You can train them, but after a few days, they will sure forget that. How are you ensuring that you give them sufficient practical exposure so that they don't forget it? These are all new concepts. Even for us, with so many years of experience, we find it difficult to remember a few concepts. Students, I feel, are not going to have an IQ level, intelligence that we have at this age. So with you, we need to, I believe, respect their knowledge and don't just train them for the sake of. If we can not just get them trained, but give them an opportunity to work on the real world projects, they will remember the concepts. They can talk with confidence in interviews. They can crack interviews with higher salaries. They can stick to their specialization without switching into IT. IT is nothing. Data science is everywhere in every industry. This is a project that we have done way back in 2013, friends, for a Chinese client. I traveled to China and then we have done this project in Beijing. But each person who enters the store is given a unique ID because they are given they were given in 2013 provision to use free Wi-Fi within the shopping mall. The shopping mall was 1 kilometer in length, 1 kilometer if you want to cover from one corner to another. And a lot of prestigious, sorry, costly brands were there. And, you know, they also give an option to download a mobile application. When you download the mobile application on your device MAC address is captured. That becomes your unique ID. So whenever you enter the shopping mall next time, if the app is on, it will locate automatically that you are in the store. So we've done a lot of analytics here. And this is an animated plot, by the way. You have to excuse me for my throat. Sorry, I'm not sure why suddenly. Okay. So people are moving around in this particular store. And if you're a person who entered with a kid, then automatically using video analytics, it will determine that you, with this UID, have entered with a kid using image analytics. Then automatically you will receive a discount coupon from Baby Care product store. Wow. If you are a person who entered with a woman of same age group, you would receive a discount coupon from women's apparel store. Maybe you want to go and purchase a handbag for your wife or for your girlfriend, whatever be it. Yeah. And electronic store on Amazon, if the price of iPhone is 80,000, which is what you have searched online, that information using the cookies gets captured. And the moment you enter the Apple store, a trigger is sent to the Apple store owner saying that this guy who entered your store has just now searched online for the price of iPhone. And the least price was 80,000. The store owner can give you an instant discount to ensure that you purchase one. If it is 82,000, they can give instant 2,000 rupees discount only for you. Ultimately, it's all about increasing the sales. And in that way, coupons, redemption prediction model for restaurants, so on and so forth, all this analysis we have done. This is how students should be given the practical use cases and we have to make them work. If it's only about drag and drop, because Tableau has a lot of drag and drop options, then they will absolutely learn nothing. And yesterday, if I'm not mistaken, I also spoke about a specific project wherein we transported or we built a model to help people understand what is the route that they have to start for TrueJet. TrueJet is now defunct, meaning it doesn't exist. But back then when we have done this, yeah, this is the one. So in this way, we have done network analytics to understand what is the source, what is the destination, what is the load factor, means how many people are booking the seats in that particular journey. And based on this network analytics, we have come up with a suggestion to have them start a route from Hyderabad to Indore. And they've actually started that route based on our recommendations. This is called as network analytics, basically. So in this way, we can build amazing applications. And this is what we intend to include. So with this, I would like to stop here and, oh, no, not really. So one more thing. So sorry, a couple of things rather, and then I will hand it over to Sudhakar Garu. So on 360 DigiTMG website, we have mind map threads. If you go to the certification program in data science, this is the mind map. What we felt eventually is that students are able to easily remember the concepts. They just need to expand it. They just need to expand it. They just need to collapse it. Just need to expand and collapse, and they can read it. This will help them for interview preparation, for their internal exams. This can help as a good, a recap, and we use it every day. We believe that if I tell you once, you might forget. If I tell you twice, you might forget. But if I'm going to tell you on all the 60 days, every day open, quickly do a recap of all the concepts and then get into my core topics, then eventually students will start remembering this. This is one thing. Second thing that we have is the digital book, because through images, we want our students to, learn. It gives you a feel as if you're flipping the book. This is called as digital. Of course, we have 600 odd pages book, only 168 pages. We have given it for free for students to access. Then we also have animated learnings. I very firmly believe that when you have animation, students are going to learn in a much better manner. Okay. So all these are the different animations that exist. For example, this is exploratory data analysis related animation, right? It would come up. Probably there is some issue here with respect to the animation. So this is yet another GIF for graphical representation. When we give these kind of things, students whom we are training are saying that, yes, we are able to remember these things as opposed to using static stuff. I mean, these are the things which are home developed, homegrown. We didn't purchase from anywhere, right? And also, we have our YouTube channel where we have approximately 40,000 subscribers. But every week, we conduct an interview preparation session, success story session with two people who got placed to us. As I told you, 560 plus people got placed until now. We have SQL for data analytics, Tableau sessions, success story sessions, animated learning, Tame the Python, model deployment sessions, interview preparation sessions specifically, right? On my channel also, we do interview prep sessions. So these are the various things which might give you some idea on how we can develop the curriculum, and we can also look at how we can jointly develop these kind of visualizations for your specialities, so that it becomes very easy. And such beautiful links to these things, etc., we can also place on your uh, website so that students always go to your website and click to come here and then learn these things. Right? So, yep, this is all that I had. Thank you so much.